Hi guys! Welcome to Lecture 13. Kahapon, diniscuss nyo ang derivatives ng trigonometric functions. And from the last lecture video, diniscuss nyo naman ang derivatives ng logarithmic functions. For today, first, we're going to introduce a new set of derivatives, which is in particular the derivatives of exponential functions. And second, we're going to talk about how to use derivative as a slope of tangent line. So, dumako na tayo sa ating first agenda for today, which is the derivatives of exponential functions. But i-recall muna natin kung ano ang exponential function. Recall from your prerequisite courses that the exponential function is just the inverse of the logarithmic function. And ganito ang form ng ating exponential function. So we have the base b, which should be greater than 0 and b not equal to 1. Then your function f of x equals b to the power of x is called the exponential function. Again, yung b natin dito ay yung base, and it is important that it should be greater than 0. Moreover, not equal to 1 dapat yan, no? Otherwise, this will be 1 to the x, which is just equal to 1. So that will just be the line y equals 1. Okay? The example of exponential functions would be 2 to the x, 3 to the x. Pwede rin siyang non-integer like 3 over 2 to the x, 1 over 2 to the x, and so on. Okay, so we have the following remark. Yung first na remark natin, it talks about the conversion from exponential function to logarithmic function and vice versa. So, tignan muna natin itong property na to. Ang log b to the x to the base b is equal to x. That is correct. Kasi by logarithmic property, you can bring down x here. So this will be x log of b to the base b. But log of b to the base b is just equal to 1. Hence you have your x. So this expression is indeed equal to x. And observe natin na ang b of to the x nga ay ang ating f of x, which we can replace as y. So therefore, ito na yung expression na yun, no? We have y equals b to the x if and only if. The equivalent siya as saying that your log of y to the base b is equal to x from this property. So this is the conversion from exponential to logarithmic and vice versa. Okay. And if our base is equal to e is the Euler's number. This is a constant equal to 2.71 something. Exponential function f of x equals e to the x is what we call the natural exponential function. So, tignan naman natin ang graphical properties ng exponential function. Here in the slide is the graph of y equals e to the x. Ang domain ng f natin ay equal sa r. Yes, because the graph extends to all values of x, element of real numbers. And yung range natin, ma-observe natin nasa positive y-axis lang siya, no? And therefore, your f, the range of f should be from 0 to infinity. Observe natin ulit, no, na inverse lang siya ng logarithmic. So, kung mapapansin nyo, yung domain ng logarithmic natin ay yung range ng exponential. At yung range ng exponential, siya naman yung domain ng logarithmic function. Okay. Same as well with the y-intercept. So, looking at the graph here, ang y-intercept natin ay equal to 1. Okay. This is because e to the 0 is just equal to 1. And then, wala siyang x-intercept because if we equate this to 0, e to the x can never be 0 because if you take the power of a non-zero number, never siyang mag-0. Okay? Moreover, obviously, the graph is increasing, pataas siya. Tingnan naman natin yung limits. So, makikita natin, as x approaches negative infinity, that means papunta siya sa left without bound. So, pagpunta siya pa ganito. And asymptotic siya dito sa ating x-axis. Or this is the line y equals 0. Hence, the limit as x approaches negative infinity of e to the x is just equal to 0. And moreover, Pag pumunta naman tayo sa positive infinity, so this part, pataas. So, nag-i-increase without bound yung function natin, no? As x approaches positive infinity, hence, the limit as x approaches infinity of e to the x equals infinity. Right? So, I hope na-recall natin yung mga properties ng exponential function. So, now let's talk about the laws of exponents. Since we're discussing exponential functions, we have here, let a b be greater than 0 and xy be an element of real number. Then first, if you have a product with the same base, you have b to the x times b to the y, then pwede mo siyang pagsamahin into the base raised to the sum of the exponents. So as an example, say we have e to the 5 times e squared. So equal lang to sa e to the, add lang exponents, which is 7. Okay? For the second one naman, it's the same for number 1, but here we have a quotient. And for the quotient, it's equal to the base raised to the difference of the powers. Mauna yung power na nasa taas minus dun sa power na nasa baba. For example, we have e to the 5 over e squared. So this just equals e to the 5 minus 2 minus ng exponent, so that's equal e to the 3. Okay? Then, kapag ang b to the x naman ay naka-raise sa y, then you can take the product of the exponents. So, for example, you have e to the 5, and then you raise the whole thing with 2. So, this equals e to the 5 times 2 is just 10. Okay? And lastly, if you have a to the x times b to the x, same yung exponent nila, then you can combine them into a single exponent x, and yung base natin will just be the product of a and b. Then ganun din, no? If you have the product of a, b, at naka-raise yung both sa x, pwede mong ipasok yung x sa parenthesis by raising both a and b into x. Example is, we have 2 to the x times 3 to the x. So, equal lang to sa, pwede mo i-combine to, take the product of 2 times 3, and then raise to x. Similarly, if you have 2 times 3, then naka-raise naman to sa x, just raise both 2 and 3 to the power of x. Okay? And now we are ready to derive the formula for the derivative of an exponential function. Let's say we have this exponential function y equals b raised to x. Ang goal natin dito is to find dy over dx. But here, meron tayong variable sa exponent. And one way to get dy over dx is to use logarithmic differentiation. We do that para mababa natin yung x dito later on. So we get the ln of the absolute value of both sides. We have your ln absolute value of y equals ln absolute value of b to the x. And again, yung x here, you can bring it down by a logarithmic property. So this will become x ln b. The next step for logarithmic differentiation is to differentiate both sides. So if we differentiate the left-hand side, ang derivative ng ln absolute value of y is just 1 over y. Times, since we are differentiating y, maglalagay tayo ng dy over dx, equals, and then here, we just copy the constant ln b, multiply by the derivative of x, which is just 1. So this is purely in terms of x, wala namang tayo ni-differentiate na y, so this is the derivative of the right-hand side already. And solving for dy over dx, we can multiply both sides by y. So, this will cancel out. Mawala yung y dyan. And then, mapupunta lang siya dito sa right-hand side. So, we have dy over dx equals y times ln b. But again, y is just equal to b raised to x. Hence, we get this formula for the derivative of an exponential function. The derivative of b raised to x is just equal to itself, b raised to x multiplied by ln b. So, as an example, if you have 2 to the x, ang derivative lang nun ay 2 to the x ln 2. Okay? And we have this special case. If our base is equal to e, using what we got earlier, equal lang siya sa e to the x. So, magiging e to the x yun, ln b, which is just ln e. Okay? But ln e is just equal to 1. Hence, we have the derivative of e to the x is just itself. The exponential function is special in such a way that yung derivative niya ay equal lang sa sarili niya. Okay? And we have this theorem. Let u be a differentiable function of x. Then, ang derivative ng b raised to u ay b raised to u ln b times by chain rule, yung derivative ng exponent, which is du over dx. And for e to the u, ang derivative niya equal lang to itself, e to the u, times yung derivative ng exponent. So, let's illustrate this theorem by giving some example. Sinabi ko nga kanina, ang derivative ng 2 to the x ay equal lang sa sarili niya multiplied by the ln of the base, which is just 2. Okay? Wala na tayong additional factor dito because ang derivative ng x natin ay 1. But, for cases na if yung derivative ng power is not just simple 1, then we have to multiply something else. For example, we have 2 to the x squared here. So, this equals to, same lang yung process. Kopyahin natin yung exponential function multiplied by the ln of its base. Pero dito, may additional factor tayo, which is yung derivative ng exponent na x squared. At ang derivative ng x squared ay 2x. Okay? Same goes with e to the x. Ang derivative ng e to the x, again, is just simply itself, e to the x. Okay? However, if we have exponent like e to the sine x, so dito, you just copy, again, e to the sine x, but you have to multiply with the derivative of sine x, which is just the cosine of it. Okay? So, is that clear? So, don't forget the chain rule, wherein you have to multiply the derivative of the exponent. Now, we can discuss the examples. Let's start with this item. We want to get dy over dx, where y is equal to e raised to the quantity x minus cosine x plus 3 raised to tangent square x. So, if you have your pen and paper with you, pwede nyo akong sabayan sa pagsasolve. Start tayo. Pwede natin itong i-differentiate na agad kasi wala namang problem. Dy over dx equals the derivative of this one. This is of the form e to the x. So, the derivative is just itself. Copy that one. And multiply it with the derivative of the exponent. The derivative of this is, ang derivative ng x ay 1, minus, ang derivative ng cosine x ay negative sine x. So, we have this derivative for the first term. Plus, ang derivative naman nito, so this is of the form b to the x. Ano nga uli yun? You copy the exponential function, multiply by the ln of the base, ln 3, and multiply by the derivative of the exponent. Take note dito, we have to use power rule first before getting the derivative of tangent kasi naka-square siya. So, by power rule, magiging 2 tan x yan. And then the derivative of tan x is secant squared x. And simplify lang din natin. Ay yung dalawang negatives dito, naging plus here. And then, we just inayos lang natin to, no? So, combine the tan x and secant squared x. So, this would be our final answer. Okay? Now, for number 2, we want to get the derivative of x e to the 2x divided by x cubed minus 2x. So since meron tayong quotient here, ang una lang natin gagawin is to use the quotient rule. So by quotient rule, ano nga yun? Low times the derivative of high, t high, minus high times the derivative of low over low squared. Okay? So ito ang quotient rule natin. And evaluate natin yung mga derivatives dyan. For the first one, kunin natin yung derivative nito. Take note, this is a product of x and e to the 2x. So we have to use product rule here. So copy natin yung first times the derivative of the second. The derivative of this is e to the 2x. Di pa tayo tapos kasi ang derivative ng 2x ay 2. Okay? Plus, copy naman natin yung second in this time. Times the derivative of the first. Ang derivative ng x ay 1 lang. So, ito ang derivative ng x e to the 2x. And then, we have this. Ang derivative nito ay, madali lang, no? We have to use power rule lang. So, ang derivative lang yan ay 3x squared minus 2. And then, copy the denominator. Okay? And simplify lang din natin itong part na to. So, technically, inayos lang natin yung arrangement. You have 2x e to the 2x, and then yung 1 dito, we neglect it because times 1, wala naman nangyari. So, this will be our final answer. And this will be our last example for the first part. So, we want to find y prime if the log of x to the base 2 equals e to the negative y cosine x plus y. So, ang difference ito with our last example is that ang form nito ay hindi lang simple na y equals something in terms of x, right? Meron tayong mixture ng x and y on this side. Okay? So, pag ganun, ano nga yung ginagawa natin? We differentiate it implicitly. Okay? So, using implicit differentiation, ang derivative nito from our last lecture video ay 1 over x times 1 over ln of 2, right? And dito, we have to use product rule. Copy natin yung una, multiply sa derivative nitong pangalawa. Ang derivative ng cosine ay negative sign, right? So, you have negative sign x plus y. Diba tayo tapos, kailangan pa nating multiply sa derivative ng x plus y by chain rule. Ang derivative niyan ay 1, derivative ng x. At ang derivative ng y ay 1, pero since y yan, we have to put y prime or dy over dx. Okay? Plus, second part naman ng product rule, copy yung second times the derivative of the first. Derivative nito ay what? Sarili niya, e to the negative y. Pero kaya may negative dyan kasi ang derivative ng negative y ay negative 1. So, doon ang galing yung negative. And again, we differentiate something in terms of y. So, we put y prime here. Okay? So, for implicit differentiation, again, ang gusto natin ay ma-isolate si y prime. At magagawa natin yon kapag dinistribute muna natin yung mga product dito, no? Dito, specifically in this part. So, doing that, we have, so itong dalawang to, yung multiply natin sa 1. So, this is that part. And then, itong dalawang to, yung multiply natin sa y prime. Okay? So, dinistribute lang natin tong dalawa over this sum. Okay? And then, for this one, so just rearrange this, no? Such a way na yung y prime ay nasa dulo. So, solving for y prime, ang gusto natin, lahat ng may y prime sa isang side, lahat ng wala sa kabila. So, in this case, ang ginawa natin, lahat ng may y prime, pinunta natin sa left-hand side. So, itong dalawang to yon, itong dalawang terms, we move it to the left-hand side. That's why naging positive sila pareho. And then, ito, it will remain on the right-hand side kasi wala siyang y prime. But this one, we move it to the right side. So, naging negative siya. And our last step is to isolate y prime nga. So, gagawin lang natin ipa-factor out natin yung y prime. So, technically, pag factor out natin yan, y prime times this expression without the y prime equals this one. And then, i-divide natin yung naka-multiply sa y prime dito. So, you should get this one. You have y prime equals this expression divided by this expression without y prime. Kasi nga, na-factor out na natin yung y prime. So, this should be your final answer. Okay. So that's it for the derivatives of exponential function. We are now going to move on with the derivatives as slope of tangent line. So recall lang din natin, dinefine natin dati ang derivative as a slope of the tangent line given by this limit definition. So for example, sa curve na to, ang slope ng tangent line nito ay equal lang sa f prime evaluated at the x-coordinate of your point of tangency. Illustrate natin pa siya furthermore. So let's say for example, we have this curve, x squared over 4. Given yung graph niya here. We get the derivative. Pag differentiate natin to magiging 2x over 4. Pero ang 2 over 4, 1/2 lang. So, that's 1/2 x. Ibig sabihin, the slope of the tangent line at any point in the curve is just 1/2 x. So, kuha tayo ng examples for x. Let's say, ang x natin ay -1. We have this tangent line here. Okay. Ang slope niyan will just be f prime at -1. And if you solve that, that's just 1/2 times -1, which is -1/2, which is true, right? Kasi ang slope nito would be negative kasi pababa siya. At x equals 0, ito yung line na yon. At ang f prime of 0 ay 0 lang, which is true because this is a horizontal line. Ang f prime of 1 ay 1/2. And ito yung tangent line. Ang slope nito ay positive, correct? Because it's going up. At x equals 2, ito yung tangent line. At ang slope na equal to 1, which is greater than the slope here. Kita naman no, na steeper nga itong line na to than the other one. So, mas malaki talaga yung slope na. And let's recall the equation of the line. So, this will be essential for our next exercises. So, we're talking about the forms of the line here. We have 3. First is the point slope form. From the name itself, ginagamit to kapag given ka ng point at given ka ng slope. Ang slope mo ay m, ang point mo ay x1, y1. So this will be your form. Y minus y1 equals the slope multiplied by the quantity x minus x1. Ngayon, pag given ka naman ng slope m at y-intercept b, so you use slope-intercept form, that is just equal to y equals mx plus b. So take note lang dito na this is specifically the y-intercept. Okay? So not just any intercept, but the y-intercept. And moreover, meron din tayong 2-point form. Again, this is when you're given 2 points, x1, y1, and x2, y2, sorry. So, itong form na to, kung mapapansin nyo, that's just very similar to the point slope form, which is this one. Pero yung m natin ay in-expand lang natin yung formula for the slope, which is just rise over run. Okay? So, yun. Sana naalala nyo pa tong tatlong forms na to. So, let's do this exercise. We want to find the equation of the tangent line to the curve y equals x cubed minus 4 at the point 2, 4. So, from the forms of the line, ano ba yung mga pwede nating kunin? Either meron tayong 2 points, o kaya point and a slope, o kaya slope and a y-intercept. Pero dito, obviously, meron na tayong point 2, 4 because the tangent line should cross the point of tangency, 2, 4. Okay? And Since we're talking about derivative as slope, we can also get the slope by taking the derivative. Then nga, we need the point and the slope. So the 0.24 is already given to us. We just need to find the slope by getting the derivative. Okay? And taking the derivative of our curve, we have dy over dx equals, this is just, baba natin yung 3. So you have 3x squared, and derivative of this is 0. So you have 3x squared. So again, the slope of the tangent line will just be f prime of x evaluated at the x coordinate of our point of tangency. So dito, ang point natin ay at x equals 2. So makukuha nating slope would just be, substitute lang natin yung 2 dito. So you have 3 times 2 square, which is just equal to 12. So this 12 represents the slope of the tangent line to the curve at the point 24. And now, meron na tayong point, meron na tayong slope. We can use the point slope form. Ano nga yun? Y minus y1, y1 is 4, equals m, which is our slope 12, times x minus x1, which is x minus. Okay? So now we introduce a new line, which is related to our tangent line. We have here the normal line. So a curve at a point is the line passing through that point and perpendicular to the tangent line at that point. Let's say for example, again, itong curve na to, ito ang tangent line at the point AB. Ang normal line natin will just be this perpendicular line to that tangent line passing through the point AB. Okay. We do this one. Find the equation of the normal line to the curve y equals 4x squared minus 8x at the point 2, 0. So, analyze muna natin yung problem na to. Imbis na tangent line yung pinapahanap sa atin, pinapahanap yung normal line. Again, we need the point and the slope. We already have the point here. So, kailangan na lang natin kunin yung slope. Pero since perpendicular ang normal line at tangent line, pwede nating i-relate yung slopes nila. And we have this relationship. Recall, kapag meron tayong dalawang perpendicular lines, ang slope nila will just be the negative reciprocal of each other. And applying that here, ang slope ng normal line na equal lang sa negative ng 1 over slope of the tangent line. So again, we have the negative reciprocal. So to do this, kunin muna natin yung slope ng tangent line, then tsaka natin makukuha yung slope ng normal line. So ang slope ng tangent line ay derivative lang nito. We have dy over dx equals, derivative of this is 8x, derivative of this is 8, so 8x minus 8. And we evaluate this at x equals 2, because we have 2, 0. So dy over dx at x equals 2 is just 8 times 2, 8x minus 8. So 16 minus 8 or equals 8. So kung ang slope ng tangent line natin ay 8, ano ang ating slope ng normal line? Ang slope niya will just be, negate it, negative 8, and take the reciprocal, you have negative 1 over. Okay, so negative reciprocal. And using the point slope form, we have the slope negative 1, 8, and the point 2, 0. So that's just y minus 0, or just simply y, equals the slope negative 1 over 8 times x minus 2. Okay? So, sa paggawa ng normal line, same lang ang process, pero may additional step lang tayo na kailangan natin kunin yung negative reciprocal ng slope ng tangent line kasi nga perpendicular sila to each other. Okay? Now, we're given another function, 3 minus 2x all over 1 plus 2x. We want to determine the line tangent to the graph at point where x equals 0. So, two important things again, point and the slope. Pero dito, kulang yung point natin, no? Kasi ang given lang ay x equals 0. So, we have to get the y coordinate first. And we just do that by substituting 0 in f of x. So, we have f of 0, the y coordinate, to be equal to 3 minus 2 tangent 0 over 1 plus 2 cosine 0. Ang tangent 0 ay 0 lang. So, we have 3 divided by, ang cosine 0 ay 1. So, magiging 1 plus 2. So, this is 3 over 3, which is just equal to 1. Okay. Therefore, ang point of tangency natin will be the point 0, 1. Next, slope. Get the derivative. F prime of x equals quotient rule, low, this one, times d high. Ang derivative nito would be, ito 0 to, no? Constant lang yan. Minus 2, ang derivative ng tangent ay secant squared. So, ito yon. Minus high, copy high, d low. So, derivative ng 1 ay 0. Derivative ng 2 cosine ay 2 times negative sine x, which is negative 2 sine x, over the denominator square. We have this derivative. And we evaluate this derivative at x equals 0. At x equals 0, kunin natin ng f prime of 0. So, equal siya dito sa expression na to. And if you check, dapat mag-equal siya sa negative 2 over 3. So, check nyo na lang yung mga values ng trigonometric functions at x equals 0. And you should get negative 2/3 here. Okay? So, we have the slope negative 2/3. And yung point again natin ay 0, 1. Okay, from our first step. So, hence, by the point slope form, we have y minus 1 equals the slope negative 2/3 times x minus 0. And if I want it to be in the form y equals mx plus p, transpose ko lang yung 1 sa kabila, no? So, ito magiging negative 2/3 x lang to. Wala na tong 0 dito. Tapos transposing 1, we have plus 1. So, this is the slope-intercept form of our tangent line. Okay? This will be our last example for this lecture video. We want to determine the equation of the line normal to the curve given by this equation, e raised to the quantity 2x minus y equals y minus x at the point 1, 2. Again, point, slope. Okay na tayo sa point, 1, 2. And we get the slope by differentiating. So, here we have to use implicit differentiation kasi ang both sides ay mixture ng x and y. Differentiating both sides. For this part, for the left side, we have the derivative of an exponential function. So, copyin lang natin. Times derivative ng exponent, so x minus y. And equal siya sa derivative ng y minus x. Ang derivative ng y ay 1 times dy over dx. Or dy over dx. And derivative nito ay 1 lang. So, we have here, i-fill out natin to. Anong derivative ng 2x minus y? Just 2 minus dy over dx, derivative ng y. So, here hindi natin papakita yung details, pero same lang siya sa ginagawa natin kanina and from the last meeting. Dito, kailangan nyo lang ito i-factor out. Isolate dy over dx on one side. Tapos, factor out dy over dx. Kung ano man yung nakamultiply sa dy over dx, i-divide natin yung whole expression para dy over dx na lang yung one side. Okay, sige, I will give you some time to do that. Okay, and you should verify na ito yung makukuha nyo. Okay, so again, dapat ang nakuha nyong dy over dx is this expression. And ngayon, ang gagawin natin, since kinukuha natin yung slope at this point, so sa-substitute natin yung point na to. Ang kaiba nito doon sa previous example, yung dy over dx natin is in terms of both x and y. So in this case, hindi lang x yung isa-substitute natin, but also the y. we replace x with 1, and we replace y with 2. So we have this. Okay. So yung taas, we have 1 plus 2e to the 0. E to the 0 is 1. So you have 1 plus 2 here. So this is just 3. And then e to the 2 minus 2, this is e to the 0 again, which is just 1. 1 plus 1 is 2. So you have the slope as 3 halves. Pero hindi ito ang gagamitin nating slope kasi nga normal line ang hinahanap sa atin. And that will just be the negative reciprocal. So ang slope ng normal line is, reciprocal nito ay 2/3, get the negative of that. That will be negative 2 over 3. So now we have the slope of the normal line, the point of tangency. So we have this point slope form, y minus 2 equals negative 2/3 times the quantity x minus 1. So pag in-expand natin, magkakaroon tayo ng negative 2/3 x plus 2/3. Okay. Furthermore, yung negative 2 dito, pwede nyo i-transpose here. So magkakaroon ka ng plus 2/3 plus 2 sa constant na part. And 2/3 plus 2 is just 8/3. So therefore, our normal line in the slope-intercept form will just be y equals negative 2/3 x plus 8 over 3. So again, to summarize, kung hinahanap nyo ang tangent line at the normal line, so kailangan nyo ng point, which is usually given, you have to get both x and y. So kung x lang yung given, you have to substitute x to the function to get y. Or if y lang yung given, you have to substitute y to get x. Also, you need to have the slope, and you can get the slope. Pag tangent line yung hinahanap, ang slope lang niya ay derivative, evaluated at the point. Pag normal line, kunin nyo muna yung slope ng tangent line and take the negative reciprocal of that. And then lastly, use the point slope form using the point of tangency and the corresponding slope that you got from the previous step. I hope nakasunod kayo sa ating lecture at sana sabayan niyo ako while doing the items. At ito ang more examples para makapag-practice pa kayo on this topic. Bye guys!